let's just see the basic proportionality theorem. That what is the basic proportionality theorem? Always remember this basic proportionality theorem is also called as Thales theorem. So Thales theorem, basic proportionality theorem is one of the same thing, and we also called it as BPT theorem, means BPT theorem of the basic proportionality theorem. Now let's just see what is basic proportionality theorem. So the theorem says that if a line is drawn parallel to one side of a triangle to intersect the other two sides in the distinct points, then the other two sides are divided in the same ratio, Now let us suppose if I'll draw the figure for this one. So it actually says, let us suppose if I have a triangle. So let us suppose if I'm drawing a triangle over here, and this is my triangle. Let us suppose if I'm taking this as my triangle. So this is my triangle, and I'm calling it as nothing but A, B and C. So this is my A, this is my B, this is my C. So let us suppose if I'll write it over here, that what is given to us, so the given condition is nothing but a triangle A, B, C, a triangle A, B, C, and a line, and a parallel line, let us suppose if I'll draw a parallel line over here, and a parallel line intersecting, and a parallel line intersecting, and a parallel line to BC, intersecting the other two sides, that is AB and AC at D and E. Let us suppose if I am taking this point as D, this point as E, this point as D, and this point as E. Now what we have to prove over here, so let's just write what we just wanted to prove. So to prove, we just wanted to prove that this ratio is similar, or this ratio is equal, means AD by DB is nothing but is equal to AE by AC. According to the question, it says we have just to prove that two sides are divided in the same ratio, means we just wanted to prove that AD by DB is nothing but is equal to AE by EC. So we just wanted to prove this thing, that AD by DB is actually is equal to AE by EC. Now let's just see further what we can say about some construction which is related with it. So the construction that we require is, let us suppose I'm starting with join BE and CD. So the very first construction is we have to join this BE and we have to join this CD, and further draw EF perpendicular to AB. So let us suppose if I am drawing EF which is perpendicular to, let us suppose if I'll write from this side, this is my EF, that I have drawn perpendicular to AB, and further and DG perpendicular to AC, and DG, let us suppose if I am taking this as G, this is my G, DG perpendicular to AC. This is my construction that I require in order to prove that this ratio are similar to each other. Now let's just move on further towards the proof. So let's just start the proof of this. So first of all, in order to prove that AD by DB is equal to AE by EC, I am just taking the triangle as nothing but the triangle which is BDE. DE. So I am starting everything with the triangle B, D and E. So let's just start taking the triangle B, D, E. So as you can see that we know the area of a triangle, is actually half into base into height. So using this particular concept, we will talk about the ratio. So as you know, the area of the triangle is nothing but half into base into height. So if I am talking about in triangle BDE, then the area of the triangle BDE would be nothing but is equal to half into base. As you can see, in triangle BDE, the base is BD. So this would be BD or DB, you can write DB into height. So as you can see, for the triangle BDE, the height is nothing but this perpendicular, which is EF. So its height is nothing but EF. So let us suppose I am calling this as equation number 1. This is my equation number 1. Now in the similar manner, I am just talking about the triangle ADE. Now again, we can say that the area of the triangle ADE is again half into base into height. So let us suppose if I am just talking about the triangle ADE, then in the triangle ADE, if I am taking the base AD, as AD, so I can write half into base is nothing but AD, and further the height AD, and further the height is definitely again EF. This is definitely again EF. If I am taking the ADE triangle, then for the base AD, we have the height as nothing but this EF. So this would be again EF. Let us suppose if I am taking this as equation number 2, and now I am dividing these two equations, that is the area of the triangle ADE and area of the triangle BDE. So let us suppose if I am just moving on further by dividing these two areas, so we are taking divide or dividing 1 and 2, we will get, let us suppose if I am taking this one in the numerator as area of the triangle ADE by the area of the triangle BDE is nothing but is equal to half into, further let us suppose if I am taking half into AD into EF divided by half into DB into EF. So this is actually what I am getting after dividing these two particular areas. So let us suppose if I'll cancel all the values that I have, half and half get cancelled, EF and EF get cancelled. So actually I am getting that the area of the triangle ADE divided by the area of the triangle BDE is equal to AD by DB. So let us suppose if I am calling this as my equation number 3rd, and I'm just putting it under this particular rectangle, because this is my main important condition that I have get over here. Now again, in the same manner like we did for the two triangles BDE and ADE, for these two type of triangles, now I'm just taking the triangles that is on this particular side. So let's just starting with the triangle again. In triangle ADE, let us suppose if I'm talking about the triangle ADE again, now I'm just taking the base of the triangle ADE as nothing but AE. So the area of the triangle ADE is again half into base, and now I am taking the base as nothing but AE. I am taking the base as AE and I am taking the height. If the base is AE, then its height is nothing but DG. So it means the area of the triangle ADE is nothing but half into base is AE, and height is nothing but DG. As you can see over here that if I am taking this as nothing but the base, this is the base, then height is DG. Now again, if I am taking the area of in triangle, I'm taking now the triangle as CDE. In triangle CDE, now again I'm taking the area of the triangle CDE as nothing but is equal to half into base. So I'm just taking the base as nothing but EC. So this is my base EC, and height again is DG. As you can see over here, for CDE the height is nothing but DG. Now again, if I'm taking these two as nothing but equation number 4 and equation number 5, let's just divide these two equations again in order to get the value. So let us suppose if I'm dividing these two again, dividing 4 and 5. So if I'll divide these two again, so we will get the answer as nothing but, the area of the triangle, ADE by the area of the triangle CDE is nothing but is equal to half into AE into DG divided by half into EC into DG. Now let's just cancel out the values whatever are cancelling with each other. So as we can see, half and half is getting cancelled with each other, DG is getting cancelled with each other. It means at the end we are getting area of the triangle ADE by area of the triangle CDE is equal to nothing but AE by EC. Now let us suppose I am calling this as nothing but my equation number 6. Now if I'll compare the equation number 3 and equation number 6, then I can see that we have area of triangle ADE, we have area of triangle ADE, but we have the denominators of these two different from each other. The denominator, as you can see, area of triangle BDE, and we have over here as area of triangle CDE. So let's just see these two triangles. So we have BDE is nothing but this triangle. Let us suppose if I'll just shade this portion. So this is my very first triangle, that is the triangle BDE. This is my very first triangle BDE, and the second triangle is nothing but CDE. The second triangle is nothing but CDE. So as you can see, CDE is actually this triangle. This triangle is CDE. This is the triangle CDE. This is the second triangle CDE. Now, as you can see, if I'm just talking about only these two triangles, so we can say that since the triangle BDE and triangle CED are lying on the same base, they are lying on the same base DE, and between the two parallel lines, that is DE parallel to BC, it implies that the area of the triangle BDE is nothing but same as that of area of the triangle CDE. So hence we can see over here that we know the concept that whenever we have any particular two triangles which are lying on the same base and between the same parallel lines, then their areas are always equal. So if we are using this particular concept over here, it implies that both of the areas are actually is equal to each other. And now again, let us suppose if I am taking this as nothing but a seventh equation, so we can say using the equation 3rd, 6th and 7th implies that area of the triangle ADE by the area of the triangle BDE is the same as that of the area of the triangle ADE by the area of the triangle CDE, which is nothing but is equal to AD by DB, which is nothing but is equal to AE by EC. So hence at the end what we have concluded? We have concluded that AD by DB is actually is equal to AE by EC, and this is the thing that is required to prove, because we just wanted to prove that AD by DB is nothing but is equal to AE by EC, and hence this is nothing but the thing which is required to prove. So the answer would be like hence proved the theorem. Hence prove the theorem. And also remember, this is also called as the Thales theorem. So let us suppose if I'll write it over here, this is also called as the Thales theorem or the proof for the basic proportionality theorem, in which we just wanted to prove that AD by DB is actually is equal to AE by EC. So this is the proof of the theorem number 1, which is called as the basic proportionality theorem. I hope all the steps related to the basic proportionality theorem is all clear to you.